Welcome to today's lesson on multiplying decimals. Here are today's goals. Students will be able to identify the steps of multiplying decimals and will be able to solve decimal multiplication problems. Now before we can multiply decimals, we need to remember just how to multiply 2 to 3 digit numbers without decimals. I'm going to show you two different ways to approach it. I want you to pick what works best for you. But what's important is I do want us to get away from lattice. I want you to pick one of the ways I'm going to show you now. I'm going to add an additional short video to this web page that will just review multiplying 2 and 3 digit numbers. Alright, here's the really traditional approach that probably your parents use and maybe a lot of you use as well. Here we go. I'm going to do 6 times 1 is 6, then 6 times 8 is 48, and that's my answer. So again, 6 times 1, and then I do 6 times 8, and I get 486. Let's try this one. 3 times 5 is 15. Now I'm going to put down the 5 and carry up the 1. Then 3 times 1 is 3. Now you need to add this extra 1 that we carried. So 3 times 1 is 3, plus 1 is 4. Now we need to do 3 times 2 is 6, and my answer is 645. So again, we multiplied by the 5, then the 1, and then the 2. In our last problem, we're going to do 2 times 5 is 10. We have to put down the 0, carry the 1. 2 times 2 is 4, plus 1 is 5. Now we need to multiply the tens. Because I'm multiplying the tens place, I'm going to drop a 0. So now we'll do 1 times 5 is 5, and 1 times 2 is 2. Now remember, this was from the first, so we're not going to use that. 1 times 5 is 5, and 1 times 2 is 2. Then I would simply add those together. 0 plus 0 is 0, 0, carry the 1, 2, and 3, and get 300. If that is how you do it, then great. If you understand that, fantastic. You can just skip the next part of this and move on. For those of you that really want to understand better why this is working, let's try it using more of a distributive property. This might make more sense to you. All right, we're going to do 6 times the ones place, which is 6. Now, this 6 times 8 is really, we know 6 times 80, which is 480. And then we're going to add them back together and get 486. So this is using the distributive property. 6 times the ones, 6 times the tens, and add it back together. Let's try that over here. 3 times the ones place, 3 times 5 is 15. Now we're going to do 3 times 1, but remember that's really 10. So 3 times 10 gives us 30. Then 3 times 2, which is really 200. So 3 times 200 is 600. So what we did is we just multiplied by each part, but don't forget your place value. And now we're going to add it back together. We're going to get 5, 4, and 6. Same answer as we did the way I did before. Let's try that here. 2 times 5 is 10. 2 times, this is really 20, so 2 times 20 is 40. Now we need to multiply this way. This one is really a 10, so 10 times 5 is 50, and this 10 times 20, 10 times 20 is going to be 200. Now we can add all of that back together and get 5, 9, 10, carry the 1, and get 300. Do what works best for you. Again, if you need more help with that, watch the additional video for more review. All right, so let's take a look at multiplying decimals. When you multiply decimals, you can use estimation to help you determine the position of the decimal point in the product. Remember, product is the answer to a multiplication problem. First, what we're going to do is look at each problem. We're going to estimate each product. Then we're going to find the actual answer and see how close that we really are. All right, let's look at this first one. I have 4 and 235 thousandths times 16 and 9/10. I'm just going to estimate this using front-end estimation. So let's just do 4 times, this is close, well, 4 times 16. And that is going to be about 64. So that is going to be my estimate. So I know that my real answer needs to be pretty close to that. So now what I'm going to do, I want you to try, let's try this. I'm going to multiply this by this, but leave out the decimals. So on my calculator right now, I'm doing 4235 times 169. For right now, I'm leaving out the decimals. Here's what I got. 715715. Now, if I know that my answer needs to be close to 64, where in this number am I going to put the decimal? If I put it here, then I'm saying it's 715. That's way too big. If I put it here, I'm saying 7. That's way too small. So it looks like if I put the decimal here, that's going to be the closest to 64. All right, let's try this one. 78 hundredths times 568. I'm going to round this to 1 and keep this at 568. So 568 times 1. This answer is going to be close to 568. Let's try estimating. I'm just going to do 78 times 568. So what I did is I multiplied these two numbers without a decimal point on my calculator. Here's what I got. 44304. Now, according to this, let's see where it would make the most sense to put the decimal. This number's in the hundreds, so I'm going to put my decimal right here. 443 is closer to 568 than like 44.3 or 4,000. Let's try this one. 56 and 1/10 times 23. Let's round to the nearest tens place. So let's do 60 times 20, which would be 1,200. Now I'm going to multiply these two numbers with no decimal point. So on my calculator, I'm typing in 561 times 23, and I get 12903. Now this is 1,200, so where does it make the most sense to put my decimal? Well, 1,200, we'd want to put it right here. 1,290.3 is pretty close to that. Last one. 15 and 6/10 times 2 and 15 hundredths. Let's round to the nearest ones place. So I'll do 16 times 2. So it's going to be about 32. I'm going to go ahead and multiply this. 156 times 215. And I get 33540. My answer needs to be close to 32, so it makes the most sense to put my decimal right there. Now the reason we did this activity is because multiplying decimals is very different than adding and subtracting. When we added and subtracted, we placed our decimals first. Then we put in our numbers and solved. You will find today that when we multiply, we're actually going to multiply the numbers first and place our decimal last. Estimation can help us to do that. All right, I want to take a look quick at what it means when we're multiplying decimals because a lot of people find this pretty confusing at first. So first, let's think of two ways to say 3 times 17 hundredths. Well, we just studied what are some ways to say times. How about 3 groups of 17 hundredths? All right, so let's show that over here. I'm going to pull out my highlighter again. And let's do one group of 17 hundredths. That looks like this. Now let's do a second group of 17 hundredths. And now let's do a third group of 17 hundredths. So if I do 3 groups of 17 hundredths and I look at how much is shaded all together, I can see I've got 3 whole tenths, and then I've got 7 plus 7 plus 7 hundredths. So that's 21 hundredths. So altogether I've got 51 hundredths. So that is going to be my answer. And then you can see if you can find another way to say this. We could also say 3 times 0.17 means 17 hundredths plus 17 hundredths plus 17 hundredths. And that's what we did right here. So if we added all those together, we would still get 51 hundredths. All right, let's try this one. This is where people really get thrown. A whole number times a decimal, that we kind of understand that to say 3 groups of. But what exactly does this mean? 2/10 of 6/10. In this problem, I want us to see multiplication using the word of. Let's go to a simple example. When we do 3 times 4, we're saying 3 groups of 4. Well, when we say 2/10 times 6/10, we're really saying, what is 2/10 of 6/10? How much is that? Well, here's how we're going to do that. Let's make this into a story problem. I have 2/10 of my brownies left. So I'm going to go ahead and shade in 2/10. I'm sorry, let's switch that around. If I have 2/10 of 6/10, that means I have 6/10 of my brownie left. So let's shade in 6/10. All right, so I have 6/10 of my brownie left. Well, I came home from school today and I ate 2/10 of the 6/10 that were left. So we're actually taking part of a part. So I'm going to take another color highlighter and I'm going to highlight the other way. So this way I shaded 6/10 of the whole pan of brownies. Now I'm going to shade 2/10 horizontally. So this is 2/10, 1, 2, of the whole pan of brownies. So what we want to know is we took what was left and we split it into 10 groups and we shaded 2 of them. So how much of the brownie pan did I eat if I ate 2/10 of the 6/10 that was left? Well, right here shows you how much I just ate. I couldn't eat this part because that part was already gone. So this is 2/10 of what was left, 6/10 of the pan. So if we add that, or if we figure that out, we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hundredths is how much I ate. So that is another way to look at a decimal times a decimal. You're saying how much is this part of this part. Now we could also, decimals are really the same as fractions. Another way to write this would be, what is 2/10 of 6/10 of the pan of brownies? So I know that seems a little bit weird. We'll look at that again later, but just to give you a quick idea of really what's going on when we multiply decimals. All right, well, let's go ahead and give it a try. So go ahead and make your T-chart. Your heading is multiplying decimals. Example, explain. Pause, get this set up, and then we'll be ready to roll. All right, so let's go ahead and do this. Step 1. I always want you to write your problem up and down or vertically. So let's go ahead and rewrite this. Now, just like in normal multiplication, you generally want to put the number with more digits on the top. So we'll put 0.05 times 0.9 or 9/10. That is step 1. Don't leave it horizontal. You need to put it up and down. Step 2 is just multiply the numbers like normal. Forget about the decimal right now. I want you to absolutely forget about it. So when I look at this problem, all I'm going to do is say, well, what is 9 times 5? And that's 45. And 9 times 0 is 0. Which I can write, but I really don't have to. All right, now, this is the important part. You're going to underline and count the number of digits after the decimal in the problem. Okay? Why do we do that? Well, that is the number of digits after the decimal in the answer. Now you're probably going to need to pause to write that down. I know that's a little wordy, but it's super important. So pause, get that written down. All right, so what do I mean by that? This is your tool. We're going to go to our problem, and you are going to underline and count how many digits are after the decimal place in the problem. So here goes. Here's 1, 2, and 3. So we have 3 digits after the decimal in the problem. Then we need 3 digits after the decimal in the answer. So we're going to start this way and work backwards. So I'm going to say 1, 2, and 3 and place my decimal. Now if you have to go over and you run into blanks, you're just going to add zeros as placeholders. Let's double check. 1, 2, 3 after the decimal in the problem. 1, 2, 3 after the decimal in the answer. Let's try another example. All right, so we're going to do 1.6 times 0.08. First step, write it vertically. 1.6 times 0.08. That's step 1. Step 2, multiply like you normally would. Forget about these decimals. 8 times 6 is 48. Carry the 4. 8 times 1 is 8. 9, 10, 11, 12. So if I just do 8 times 16, I get 128. Now, lastly, we need to place that decimal. Count the number of places, decimal places in the problem. So let's underline and count. 1, 2, and 3. Now let's underline and count in the answer. 1, 2, and 3, and that's where our decimal goes. Again, let's double check. 1, 2, 3, 1, 2, 3. 128 thousandths is my answer here. Let's try one more. First, set up the problem vertically. Okay? Then just multiply like normal. Forget about the decimals. What is 123 times 4? 4 times 3 is 12. Carry the 1. 4 times 2 is 8. Plus 1 is 9. And 4 times 1 is 4. Now let's count decimal places. 1, 2, 3, 4 in the problem. 1, 2, 3, 4 in the answer. Now I don't want to leave this as a blank. I'm going to put in a 0. Let's double check. 1, 2, 3, 4, and 1, 2, 3, 4. Please pause. Make sure that you have done all of these problems and that that's making sense. All right, you're going to go ahead and work on this on your own. Again, if you need to review how to multiply 2-digit, 3-digit numbers, please do that. Good luck.